Okay, in this video we're going to look at p-values. So it's another way of carrying out a hypothesis test. If we look here, this is how we get our p-value. So the p-value is 1 minus the probability of our gotten z-score, so you have to get a z-score first, take it away from 1, multiplied by 2. If our answer, p-value, is greater than 0.05, then we can accept or fail to reject our null hypothesis. Okay, so our null hypothesis is correct. However, if our p-value is less than or equal to 0.05, then we'll reject our null hypothesis. Right, I want to show you something here. So here is our normal distribution. And we know already that 95% of the data lies within 2 standard deviations either side of the mean. 2.5 lies on the top end and 2.5 lies on the bottom end. Okay, so outside the 2 standard deviations. So basically 5% of the data will lie outside 2 standard deviations either side of the mean. Right, that's very important for us. That means if I was to take samples of stuff that only 5% of my samples of whatever within that normal distribution would lie out here. Okay, all the rest would lie in here. Right, we can use that to our benefit. Let's have a look at this question here that I'm after kind of railing off. Right, so we have a normal distribution with a mean of 100. Let's just say this is a sweet shop, and the sweet shop do these penny sweets. Okay, I'm probably showing my age now, right, saying penny sweets, but all these little jellies. And they say that in their bag of jellies, each bag of jellies has a mean amount of sweets of 100. Okay? And they also say, but there is a standard deviation, so they're not going to count them all perfectly, so there's a standard deviation of 10. And we know that 2 standard deviations this way will get us to 420, and 2 standard deviations the other way should get us to 80. And we know then that 95% of the data lies within these 2 standard deviations. So basically 95% of those bags of sweets should have between 80 and 120. If they do, then we can say, yeah, okay, fair enough. The mean is probably 100. The shop is telling the truth. However, if we find that actually no, some of the bags of sweets have more than 120 or less than 80, well, that means the data is lying outside that 95% confidence interval. And if the data lies outside that confidence interval, basically the other 5%, the 2.5% here and 2.5% there, well then we can say, well actually no, we don't think that the mean amount of sweets in the bag is 100. Okay, so that's really our hypothesis test. So the best thing we can do is get straight into this question. A merchant sells coal in bags of 50 kg. The merchant claims that the bags have a mean weight of 50 kg and a standard deviation of 1.2 kg. To test this claim, a random selection of 72 bags were weighed and found to have a mean weight of 49.7 kg. So then we're asked to conduct a hypothesis test at the 5% level of significance using the p-values. Okay, well the first thing we have to look at is this a sample mean question or a population proportion question? So are we comparing 2 populations, okay, or a sample against a population, or are we comparing a mean against a mean? If we're comparing a mean against a mean, well then it's a mean question. So let's have a look. Merchants claims that the bag has a mean weight of that, and we take a few samples and we have a mean weight of this. So we're comparing 2 means. Okay, the mean that he claims, the mean that we find out, or that the test says. Right. So if we're doing that, we're going to be getting this type of z-score. our standard error is going to be this. Okay, as you notice, the bottom bit, this bit here, will change depending on whether it's one of the mean type questions or whether it's the population proportion type questions or whether it's just a normal z-score. Right, so let's go. So z equals, well, our score is, or the score that's found out from the sample is 49.7 minus what they claim, which is 50, all over the standard deviation is 1.2, and that's all over the square root of n, which is the sample size, which is 72. Okay, so if we type all that into the calculator, we'll get minus 2.12. So I have my z-score of minus 2.12. Just going to sketch this out. So minus 2.12 is somewhere back here. Remember, this is symmetrical, so I want to find out the probability of getting less than 2.12. Sorry, less than minus 2.12, and also, as I said, it's symmetrical, so also the probability of getting more than 2.12. So all I really need to do is get the probability of getting less than minus 2.12 and then multiply my answer by 2, because remember, the probability of getting this here is the same as getting the probability of getting that. Hence my formula here, which is 1 minus the probability of the z-score multiplied by 2. So we should know anyway how to get this probability. Remember, it's to this side of the line, and we're going to find out the probability of getting less than it. So what we do is we would say 1 minus the probability of that. Okay, that will give us getting this probability, okay, of less than minus 1.2. And when we get our answer, then we'll multiply it by 2, and that will give us then the probability of getting this and this. Okay, so let's do that in our logbook. Okay, so that's 4 minus 0.9830. Okay, and we have to read that from my logbooks. So that will get us 0.017. I'll have to multiply that by 2, and that will give us 0.034. Now I have to ask myself, is this greater than or less than or equal to 0.05? Well, 0.034 is less than or equal to 0.05, and what we said was if our p-score is less than or equal to 0.5, we reject the null hypothesis. Okay, right, hope that helped, guys.